Hey guys, we're going to look at chapter 7-2 today. It's called Congruence. This lesson starts on page 521 in your book. There is a new vocabulary word and it is corresponding parts. Corresponding parts refers to the angles or sides of a figure that match or correspond to the angles or sides of another figure. So I have two right triangles here. They are the same shape, they are the same size, they are oriented differently. However, they are congruent because they are the same shape and same size. You'll see that I have highlighted the side lengths in blue and the angles in pink. So these are called tick and arc marks. Tick and arc marks. So if you see a side length that has one tick mark, it corresponds with the side length of the other shape that has one tick mark. But what that basically means is that these two side lengths are the same. We don't know what their dimension is necessarily, but we know that they're equal. So the side that has two tick marks corresponds with this side. The side that has three tick marks corresponds with this side. Arc marks. I have an arc mark here. It's just one, corresponds with this one. I have two arc marks sort of at this 90-degree angle, corresponds with this angle, and I have three arc marks which corresponds with this angle here. Okay, so and here's a little bit of shorthand for you. You're going to have to write congruent statements in this homework. So instead of writing out corresponds with every single time, you can use this symbol. It's basically an equal sign with a little squiggly line up above it. It means corresponds with. Okay, let's go ahead and jump into example one. We just talked about this corresponding angles and sides. So here's what you're going to do today is they're going to give you two figures and they want you to write corresponding statements where you're basically saying, hey, I'm going to list off all the angles that correspond with each other and I'm going to list off all the side lengths that correspond with each other. For example, we won't do all of these, but let me see, I'll be consistent here. I put tick marks in blue and arc marks in pink. Okay. So let's see here. Angle J is here, corresponds with, it has one arc mark, so that means it's going to correspond with angle G. So you're going to write the congruent statement. This symbol here, remember, means angle J, corresponds with, there's that symbol, angle G. So you're going to go through here and you're going to write the statements for each angle, right? L has two arc marks, it's going to correspond with I, so on and so forth. H is going to correspond with K. Okay, so that's going to bring us to the corresponding sides. You're going to notice that the corresponding sides have two letters. It doesn't matter which letter is written first. You can call it side length JK, you can call it side length KJ, it doesn't matter. The order of the letters doesn't matter. Okay, so let's take a look here. Correspond JK, let me find JK, J to K, so that's this side here, has one tick mark. It's going to correspond with this side here, which also has one tick mark. So you're going to write the two letters, right? So at what angle does the line start at what angle does the line end at, and you're going to put a line above it. That signifies side length. Okay, so side length JK corresponds with side length GH or HG, it doesn't matter. KL or LK corresponds with HI or IH, that's two tick marks. And the last one, LJ, corresponds with IG, that's three tick marks. So you're just going to, this is the answer. You're just going to write this corresponds, a statement of correspondence, right? Okay, so here is A for you guys to try. This is a four-sided shape, a quadrilateral. So in this case, you're going to have four side lengths and you're going to have four angles. So I went ahead and I started with, it doesn't matter whether you compare this shape to this one or this one to this one. The order doesn't really matter here. You have some flexibility. So I'm starting off with side lengths this time. Side length AB, that's this side right here. That has 1, 2, 3, 4 tick marks, right? That's going to correspond with The other shape's side that also has 3 tick marks, in this case, is going to be MN. MN or NM. It doesn't really matter. So let's see here. I'm going to go ahead and finish that. The angles. So let's see here. Angle A. Let's see if I can find angle A. Angle A is right here. What angle do you think is going to correspond with in this shape? Well, it has 1 arc mark, so it's got to correspond with M, which also has 1 arc mark. So angle A is going to correspond with angle M. Angle M. So I'm not going to go through all of these because we just did that in example 1, but you're basically just going to have 4 sets of congruent statements for the sides, and you're going to have 4 sets of congruent statements for the angles, and this is your solution. This is the answer. All right, let's go ahead and move on. Example 2 is saying that triangle ABC is congruent to triangle XYZ. Write a congruent statement comparing the corresponding parts. So it's really more of the same. The only difference here is that these 2 triangles are on a graph and they aren't giving you the tick and arc marks, which means you kind of have to make your own. So let's see here. The shortest side, AB, I'm going to give that 1 tick mark, is going to correspond with this shortest side, XY. Okay, the longest side, AC, I'm going to give that 2 tick marks, is going to correspond with the longest side here, which is going to be XZ. The sort of middle length side, this is going to be BC. I'm going to give it 3 tick marks. Okay, that's going to correspond with the middle length side here, which is going to be YZ. It doesn't matter. You could call this, you could say this is going to be tick mark, this is going to have 1 tick mark, and this one's going to have 2, and this one's going to have 3. It doesn't matter. What matters is that you have corresponding side lengths have the same number of tick marks. That's the only thing that really matters. So you're going to do the same thing now where you're going to go ahead and write your congruent statement. AB. Here's my AB. It's going to correspond with XY. There you go. And you're going to go ahead and do the same thing with the angles. Angle A. Angle A, well, AB, sort of the short side here and the long side here, that angle in between is going to correspond with X because it's also in between this shortest side and this longest side. So XY, or sorry, angle X is going to correspond with A. B, I'm going to give that 2 arc marks, is going to correspond with Y. And C is going to correspond with Z. So just like before, you're just going to write that congruent statement. You're going to say A corresponds with X, so on and so forth. So since it's a triangle, you're going to have 3 sets of each. If it's a quadrilateral, obviously you're going to have 4 sets of each. Okay, let's move on and see what else they have in store for us. So for part B, there's this parallelogram. They're calling it WXYZ. It is congruent to parallelogram KLMN. So meaning it is the same size and same shape. Obviously, they are in different locations and their orientation has changed. So they want you to write the congruent statements comparing the corresponding parts, and then they want you to determine which transformations map parallelogram XYZ onto parallelogram KLM. So this is very similar to what you did in 7-1, where you're going to have to say, hey, how did we get from here to here? What series of transformations occurred? So let's see here. I think what I'm going to do first, actually, is I think I'm going to try to work backward. That's going to help me write the congruent statement. So let's see here. Again, I'm starting with this one. This is basically the pre-image. This one is my image. So I'm looking at this and it looks to me like these are sort of mirror images. Okay, there definitely was a translation that occurred, a shift, but a shift down and a shift to the right, but I am looking at these two and the angles are in opposite positions, so I know that that means there was a reflection. So if I take this point here and I reflect it, if it's 1 unit to the right of the y-axis, I know it's going to be 1 unit to the left. Okay, and I'm going to call that x prime, just so I can keep track of my stuff. W was 4 units to the right, so I know it's going to be 1, 2, 3, 4 units to the left. W prime. Y is 2 units to the right, so I know it's going to be 2 units to the left. And Z looks like it's 5 units to the right, which means it's going to be 5 units to the left. Okay, let me go ahead and draw my shape here. I will put it just in black. And you can see now that the orientation is the same as the red parallelogram, aka the image, right? So at this point, you can say that, so like I said, we're going to work backwards. I'm going to say which transformations occurred first. So I'm going to say W, X, Y, Z was reflected Oh, that's really messy. For some reason, my handwriting has gotten messier since I've been home. Let's just start over, shall we? Was reflected across which axis? The x-axis or the y-axis? It was reflected across the y-axis. Was reflected across the y-axis. Okay, and then it was translated. So if I move x 1 unit to the right and 1, 2, 3, 4 units down, I'm going to land on n. So I'm going to say WXYZ was reflected across the y-axis and translated one unit right and 4 units down. Okay, so there is our statement of transformation. Basically, how did we map one onto the other? You might be asking why I did this backwards. Well, because of the fact that there was a reflection here. Once you get this sort of in-between shape, it makes it really easy to see which angles in which side lengths correspond with each other. So I'm going to go ahead and I'm going to do the angles first. What angle is angle X going to correspond with? Obviously, it's going to correspond with N. If I didn't have this in-between shape, it would have been much more difficult to see that with the pre-image because there was a reflection here. Okay, so let's see here. Angle W, I'm going to give that 2 arc marks, is going to correspond with M. Angle Z, I'm going to give that 3, is going to correspond with L. And angle Y, I'm going to give that 4, is going to correspond with K. Okay, so we can go ahead and we can write our congruent statements out here. Again, angle X corresponds with N. Angle W corresponds with M, angle M. Let's see here, angle Z corresponds with angle L, and angle Y corresponds with angle K. Okay, so there's all my angles. Now I'm going to go ahead and do my side lengths. So line segment XY is going to correspond with MN. Line segment XY or YX corresponds with line segment MN or NM. Okay, let's see here, WZ, I'll give that 2 tick marks, is going to correspond with ML. Line segment WZ corresponds with ML or LM, doesn't make a difference. ZY or YZ, I'll give that 3 tick marks. It's going to correspond with line segment, or side length, I should say, LK. So side length ZY or YZ corresponds with LK or KL. All right, and then the last one, XY, that's going to have 4, getting kind of squishy here, is going to correspond with side length NK. Okay, so let's see here, side length XY is going to correspond with, XY is going to correspond with KN. KN or NK. Okay, so moral of the story is that you might have an easier time if you actually take care of the translations first, because once you have that in-between shape, it makes it a lot easier to figure out which sides and angles correspond. Just make sure that you're labeling that in-between shape. I would label it the original labels. So in this case, it was X, Y, and Z. And then I just used the prime symbol to keep track of the fact that, hey, yeah, this was the in-between shape. Okay. So let's take a look. By the way, this corresponds with number 3 in the homework. Okay. Similar problem. Okay, so this is a cleaner version of what we just did. The textbook answer, not as messy as mine. Okay, so take a look. This is example 3. This is the last example. These are word problems, and it's really more of the same. These are pretty easy to do. It says Miley is using a brace to support a tabletop. In the figure, triangle ABC, or I'm sorry, BCE, that's this triangle right here, is congruent to triangle DFG. DFG, okay? They're congruent. Same size, same shape. So it tells you that if angle MCB, what does that mean? Angle MCB. I'm sorry, if the measurement of angle CEB, CEB. So basically what's going on here is this middle letter here tells us that they're referring to this angle, right? They're saying it's 50 degrees. What is the measure of angle FGD? Okay, so I'm starting with F, I'm going to G, and then, FGD, right? Starting with F, going to G, and then landing on D. Again, so that middle letter here, G, they're really referring to this angle. Well, I don't know about you, but to me this looks like it's a reflection, right? So the meaning that the angles are in opposite positions in mirror image. So if E is 50 degrees, so is F. F is also going to be 50 degrees. They are congruent. Okay, take a look at part C down below in the figure shown above. The side length. So sometimes they're talking about angles, sometimes they're talking about side lengths. You have to really pay attention to what they're asking. Side length of CE, let's see, I'll put that in, how about blue? Side length CE. Oh, you know what? I'm not going to put that in blue because I already have it in yellow. I'm just going to use a tick mark. Side length, so that's right here, CE, right? I'm going to give it 1 tick mark, is 2 feet. What is the side length of FG? Well, here's FG. I'm going to give it 1 tick mark. they are corresponding. All right, they're in the same position, they have the same length, these are the same shapes, they are the same size, they are corresponding figures. So if side length CE is 2 feet, side length FG is also 2 feet. Okay, so that concludes the lesson. I am going to have you guys go ahead and get started on the homework here. There are a couple that I want to talk to you about because you may have forgotten how to do some of this stuff. So I know it's been a little while since we've done algebra. So I want you to take a look at number 5. You know what, should we do 5? Maybe we'll do, I'm going to get you guys started on 5 and 6 because they're similar. Okay, so here's the deal. It says that figure, the triangle ABC, so this triangle right here is congruent with triangle EBD. So basically these two triangles are congruent. They are the same size, they are the same shape. Okay, on the figure, draw arc and tick marks to identify the corresponding sides. I'm going to let you guys do that. Okay, I think that you can probably handle that at this point. Here's what I want to help you with is B is asking you to find the value of X. So let's see, I'm going to highlight X. I'm going to put it in orange. Find the value of X. Well, here's X. Okay. And we know that this side length here, AC, the measurements that they're giving us, the measurement they're giving us for the side length is 4x minus 2 centimeters. So what we need to do is, in order to solve for x, we need to have an algebraic equation. So we need to have something to set this equal to. Well, if you go back and you do your tick and arc marks, hopefully you're going to get that line segment AC. I'm going to give it 1 tick mark. What's it going to correspond with over here? This is basically a mirror image, right? So they're in opposite positions. So it's going to correspond with side length DE. And lucky for us, we know that side length DE is 22 centimeters. So essentially, these two sides are equal. So recall from what we've done in the past is if we know that two side lengths are equal, we are allowed to set them equal to each other. So here's my my equation. I'm going to say 4x minus 2 is equal to 22. In other words, some mystery number times 4 minus 2 has to equal 22. Well, that would be easy enough to do guess and check, but I'm going to try to be a little more sophisticated here, and I'm going to rely on inverse operations. So recall that this is algebraic. There's a variable. It's an equation. So I'm not going to do PEMDAS. That would be for a numerical expression. I'm going to do reverse PEMDAS. I'm going to undo everything that's been done to x. So try to recall, am I going to get rid of this negative 2 by adding it? Or am I going to get rid of this times 4 by dividing it? I know it's all about opposites, but remember that in this kind of, in an algebraic equation, we're reversing PEMDAS. Okay, so we're trying to get, I'm going to go ahead and bold x, right? My goal is to get x all by itself. I'm going to draw my little border so I can identify my left side and my right side. I have to undo minus 2, I have to undo times 4. Well, reverse PEMDAS says you take care of addition and subtraction first. So I'm going to get rid of this negative 2 by adding it. Okay, so now I have 4x equals, let's see here, 22 plus 2, 22, 23, 24. Okay, last step, I want to undo times 4 by dividing. Divide by 4. 24 divided by 4 is going to tell us that x is equal to 6. And you can plug it in and check. Isn't it true that 4 times 6 minus 2 equals 22. 4 times 6 is 24. I'm sorry. 6 times, it is 24. Minus 2 is equal to 22. Go ahead and subtract these two, and you're going to get a true statement. 22 equals 22. Okay, so I'm going to let you guys go ahead and do the tick and arc marks. Number 5 and number 6 are very similar. I'm going to let you handle this one, but I will help you get it set up. So in the figure at the right, they're telling you that EFG corresponds with or is congruent to triangle LMN. Find the value of X. So here's the thing, is that there's a little bit more work on the front end of this one because, so this is the hypotenuse, right? Side length MN is going to correspond with side length FG. But we don't know what FG is. They're not being as nice to us as they were in number 5, where they flat out told us the corresponding side length was 22. So we have a little bit more work here to do. This is a right triangle. You know that because of this box here. And you know that the two side lengths, or the legs of the right triangle, are 5 and 12 centimeters. So what theorem that you know of could you possibly use to find the side length of the hypotenuse? If you said Pythagorean theorem, you are correct. So go ahead and you're going to plug these two in for your legs. 5 squared, I'm going to put it up here actually. 5 squared plus 12 squared is equal to, we're going to just call this C, right? Because it's a hypotenuse, is equal to C squared. So you're going to figure out what C is. I'm going to let you do that on your own. Whatever C ends up being, right, is going to correspond with this side here, MN. So the last thing you're going to do is whatever your C ends up being, I'm going to just leave a blank space. I'm going to put it in orange. Go ahead and set it equal to the corresponding side, MN, which is X plus 3. Okay, remember when you get, so 5 squared plus 12 squared, you're going to get a pretty big number. At the very end, you need to undo C squared, right? So don't forget to take the square root so you get a reasonable response here. You don't want to have a value that's too big, it won't work. So you remember you're taking the square root at the very end. Take that, I guess we're talking about centimeters here. Whatever that measurement is in centimeters, you're going to set it equal to X plus 3, and then you're going to solve for X. So basically, all you're going to do to get X by itself is subtract 3 from both sides. Okay, one other thing I do want to get you guys started on is 7, just because it's kind of, this is messy, just a little confusing in what they're asking you to do. So there is this hexagon, it has 6 congruent sides. They want you to draw lines for CA, CF, and CE. So here's what they want you to do. I'll just kind of get you guys started here. So C to A, here's C and here's A. You're just going to draw a line connecting those two. Okay, go ahead and do the same thing for CF and CE. Once you have all of those lines drawn, they're going to ask you some follow-up questions. How many triangles were formed? So basically, how many triangles do you end up with? Go ahead and count them. And then for part C, make a conjecture about which triangles are congruent. Test your conjecture by measuring the side lengths and angles of the triangles. So spoiler alert, you're going to end up with 2 different types of triangles here. It's your job to figure out which 2 correspond with each other, right? So you're going to write, do they want you to write congruent statements? You don't have to write it for each individual side and each individual angle. You're just going to write it for the triangle, okay? So you're going to say, I'll get you guys started. Triangle ABC, right? So that's this one here. Triangle A, B, C. You're going to say which other triangle it corresponds with. So after you draw your other 2 lines, it's going to be really obvious. So you're just going to go ahead and fill it in here. And then you're going to write another congruent statement for the other set of triangles. Okay, I hope that helps. If you guys have any questions, you can find me tomorrow at Zoom. Okay, take care. Bye-bye.